हाँ हाँ हाँ, ठीक है, ये बिल्कुल सही है। आदर्श लैपटॉप लाए, लैपटॉप इधर कौन लाया? अरे मेरे, मैं अपने स्टोरेज होनी चाहिए, सर मेरे डिपार्टमेंट में से बैग रखा हुआ है। लैपटॉप है तुम्हारे, इसमें स्टोरेज है? ले आओ, ले आओ। चार्जिंग का तो इशू नहीं है कोई? है? अभी तुमको जाना होगा है ना वहाँ पे, तो तुम रहने दो। देवन जी मेरा लीजिए लैपटॉप, डिपार्टमेंट से लैपटॉप नहीं, तुम लोग को जरूरत पड़ेगी, वहाँ जाना है। बैग रखोगे, पूरा बैग ले आएंगे आपके लिए।
लिंक है सेम ही तो है।
सेम लिंक है।
लाइव स्ट्रीमिंग चल रही है।
तो देखो ये है ना कि हम लोग सेम सेटअप पे ऑलरेडी कल सब चीज़ें देख चुके थे। अब तुम उस समय चले गए थे है ना, तो इस सेटअप के साथ क्या दिक्कतें आ सकती हैं, अगर तुम होते तब हमें वो इंसाइट मिलता, तब हम उस पर बात करते। सबसे पहले इसी पे सेटअप किया था सर मैंने। हाँ वही पहले दिन बहुत दिक्कत आई, क्या देना है? मेरी मीटिंग, ये मीटिंग का क्या हुआ? मीटिंग में सर इसका इसकी नेट में दिक्कत आई है। आपके नेट में दिक्कत है, आपका नेट नहीं, मेरा नेट तो इसके वजह से चल रहा है। बेटा ये लिंक तो शेयर करो ना। ये चंद्रमा थोड़ा लेट चल रहा है, नहीं चल रहा, चल तो रहा है। ये हमारी स्क्रीन अभी शेयर हो रही है, नहीं हो रही है? हमारी स्क्रीन सर मैंने स्टॉप कर दी है। अच्छा, जरा इस पे कुछ डिस्प्ले डालो स्क्रीन पे।
चंद्रमा इधर अभी जब डिस्कनेक्ट वाईफाई डिस्कनेक्ट किया था तो ये सब छोटा हो गया। कौन सी चीज़? हाँ ये नीचे क्या दिख रहा है? कुछ नहीं।
एनआरआर कार्ड
सिस्टम पर दिख रहा है। हाँ इसकी स्क्रीन छोटी हो गई। वो स्क्रीन छोटी है, स्क्रीन छोटी कर देना, उसको स्क्रॉलिंग कीजिए। अरे नहीं वो जब डिस्कनेक्ट हुआ तो अपने आप हुआ तो। वहाँ दिक्कत तो कर नहीं रहा है लाइव लाइव पे।
अच्छा, ये तुम्हारे ना वाईफाई में कुछ इशू लग रहा है मुझे सलमान। अपना वाईफाई चेक करोगे ना, उसमें कनेक्टिविटी देखो।
मेरा वाईफाई चेक कर रहे हैं।
वो कनेक्टिविटी चली गई हमारे लैपटॉप में। किसका लैपटॉप है?
मेरा ये सब चेक कर रहा था लाइव चल रहा है।
ठीक है, ओके। चंद्रभान का इसमें क्या हुआ? सीबी है क्या है, चल रहा है क्या? बार बार डिस्कनेक्ट कैसे हो जा रहा है? ये किसका वो है कल? चार्जिंग पोर्ट किसका है? इसी का है ना ये? फीड दो उसको, फीड दो।
सर इससे जा रहा है ना वो।
A very warm and pleasant morning to our designated chief guest, respected Director Professor Manoj Kumar Shukla sir, respected Registrar Dr. PDK Patro sir, faculty members, and all the students present here. Today, I, Arvi Dubey of Electrical 4th year, am your host. We are honored to welcome you all to the Faculty Development Program on Opportunities and Challenges in Modern Power Systems.
मुझे शेयर करना पड़ेगा
Our
एक्चुअली
chief guests are
क्योंकि
our
मैं
Director
शेयर
of
करूँगा
Rajki Engineering College, Kannauj, Professor Dr. Manoj Kumar Shukla sir, and our Registrar, Dr. PDK Patro sir.
आपसे चेक करिए
Without further delay, let us begin this enlightening day. To commence
स्पेस
this FDP session on an auspicious note, I invite our esteemed guests and dignitaries to join us for the lighting of the lamp ceremony. Yes, sir.
कैमरा दो हमको, वो चाहिए उसको। ऑडियो कैसे आएगा? सर
ये जो कैमरा है कह रहे हैं इसको जूम पे दिखाने के लिए कल तो सेट था
किस पे?
उसी पे
ये दिखाना है, ये दिखाना है। ठीक तो है, इसको दिखाना है, नहीं दिखाना, इसको ऐसे ही रहने दो। ठीक है, वो चल, जो चल रहा है चल रहा है। आप इधर मैं जूम पे बोल रहा हूँ, जूम पे चल रहा है ना?
हाँ
जूम पे
सर
चल रहा है। अच्छा प्लीज़ प्लीज़,
नहीं शो हो रहा सर
क्या
ये
ये
नहीं
नहीं
शो
शो
हो रहा
होगा? वो
जूम तो कर दिया, जूम चल रहा है, जूम चल चालू कर दिया थोड़ा।
चालू कर दिया। इस पे हमें ये स्क्रीन लेनी है कि ओबीएस हो गया।
किस पर?
OBS वाली स्क्रीन लेनी है
इस पे लेनी है, आप इसमें दूसरे अकाउंट से लॉगिन करिए एज अ डमी, तो आप स्क्रीन शेयर कर सकते हैं। होस्ट नहीं हो सकते आप इस पर।
जल्दी आओ थोड़ा।
आप किसी और अकाउंट से लॉगिन कर दीजिए इसमें सीधा।
हाँ हाँ ठीक है ठीक है
तो
ठीक है,
अकाउंट तो
एग्जैक्टली।
होगा ही
मैं अपने से लॉगिन कर ले रहा हूँ।
ज्वाइन कर लेते तो नहीं मिलेगा
आप ज्वाइन किसी और अकाउंट से करिए।
इस अकाउंट से मत करो, आप किसी और अकाउंट से करो, लिंक पे
सेम अकाउंट से ज्वाइन करते हैं, अपनी स्क्रीन दिखा देते हैं, उसको एज ए वो ज्वाइन
एक साथ तो दो जगह कैसे कोई लाइव हो सकता है?
वहाँ से लाइव। हम यही तो बोल रहे हैं कि हम इसको ज्वाइन कराएंगे, सिर्फ इसका ऑडियो लेंगे।
सर फिर
फिर
दो
स्क्रीन नहीं दे पाएंगे।
दो चीज़ें एक साथ चलानी पड़ती हैं हमें, यही तो दिक्कत है। दोनों एक साथ क्यों करने हैं सर?
क्या करना है?
अभी सर आप कुछ मत करिए, जूम एकदम ठीक चल रहा है, कोई दिक्कत नहीं है।
अरे नहीं, हमें उसको फीड देनी है ना, वीडियो वाली फीड देनी है।
यूट्यूब पे कौन सी वाली फीड देनी है?
वीडियो की फीड देनी है उसको।
पिछली बार
Now,
बोला था ये वाली
to
आप लगा
honor
दो
our
इसमें, इसमें वीडियो
Dr.
ऑन कर दे तो
and
पूरा कैमरा फीड
Professor
देता है ये
Sir
वाली।
with gift of
उसको भी
यार
aroma,
लास्ट मोमेंट
I
में नहीं कर
now
सकते यार इसको
request
करो बस आप
our respected
इसमें
HOD ma'am, Shilpi ma'am, to present a bouquet and gift of aroma to him for continuing guidance and for his support. And now I invite
मैंने अपने
our
उससे कर दिया ना वो।
convener Kamlesh sir to present bouquet and fragrant token to our respected registrar sir as gesture of
मैं अपने उससे
appreciation.
कर देता हूँ।
ठीक शो हो रहा है ये तो शो हो रहा है और यूट्यूब पे ये वाला
मैं अपना ये डाल रहा हूँ बेटा।
सर ऐसा करते हैं आप ज्वाइन हो जाइए आप अपना कैमरा ऑन कर दीजिए
ऐसा भी कर
और किसी को बैठा दीजिए तो पकड़ा रहेगा
सकते हैं। ये लास्ट हो गया बेटा।
Now I
सर
request
लास्ट
our
में सर यही चाहिए
coordinators, respected Santosh Kumar Tripathi sir and Dr. Vijay Kumar Tiwari sir, to present a gift of aroma to our HOD Shilpi ma'am for her active involvement in today's event.
कहाँ से वो होगा? ये कहाँ से वो होगा? स्विच कहाँ से होगा? स्विच इसको।
Moving forward, I would now like to invite our HOD ma'am to share her thoughts and vision behind organizing this event.
सर कोई लॉगिन करा दीजिए, मैं वो
लग जाएगा।
respected guest of honor, our director sir, registrar sir, all the faculty members, and dear students. On the behalf of Electrical Engineering Department, I would like to welcome all of you in this 5 days FDP program on topic opportunities and challenges in modern power systems. First, I would like to say thank you to our director sir for motivating and supporting us for organizing this FDP. Now, this FDP contains 12 sessions including technical and hands-on sessions. All these sessions will be taken by the esteemed resource person from different institutes. Some name I would like to mention like Dr. Padmini Ma'am from IIT Jammu, Professor Ashish Sir from MNIT Allahabad, Dr. Pavli Sir from NSUT Delhi, and many more. Now, the objective of this FDP is to give the depth knowledge of what are the recent trends, innovations, challenges, opportunities, and challenges in conventional system and in modern power system. This FDP mainly includes the potentials of the system, basically like smart grid system, integration of renewable energy system, energy solar technologies, electric vehicle. These all are the opportunities in modern power system. When we go to the opportunity, there are challenges also like in the reliability of the system and the stability of system and the cyber security threats, environmental and infrastructure barriers. These all are the challenges of the modern power system. With this information, I would like to invite our respected director, sir, for his motivational speech. Thank you, sir.
Thank you very much. The organizers of this LTP,
ऑडियो आ रहा है
Mr. DCP, our registrar, Mr. DPK Padra sir, our other faculty members, and my dear students and participants. Such type of FDP which has been just started in our institute, they are very much essential for improvement in our technical knowledge as well as some other skills also as to how to present ourselves, how to grasp something new. So such type of FDP they must go on. And whatever if I talk about the topic, the opportunity challenges in modern power systems. So modern power systems has certainly lots of problems and challenges and opportunities also. Because whenever there are problems, there are challenges, there are opportunities to solve it. And once you solve it, other problems again come. Because this is a continuous process. Every time whenever you are going to solve any problem, some challenges must come. And after solving that, new challenge will come to you. So it's a process of learning, it's a process of improvement. Nothing to get worried about it. Whenever the problems comes, we improve our skills, we upgrade ourselves. In power systems, as per I know, because little bit of knowledge I have in this area, not very much. There are certain factors in the power system which includes active power conditioning also. Whenever we are maintaining the frequency and the swellings, sagging, whatever, these are different problems. Grid distribution, various parameters which are responsible for restricting the transmission of the power for the further distance, the art of transmission. And for the students, it's just a hint that they must know at least why we are having AC and DC distribution system. Like in our home, we are having AC distribution system, while for the transmission we are having DC ट्रांसमिशन सिस्टम है उससे। ऐसा क्यों है कि उसके वहाँ पर डीसी चलता है, घरों में एसी चलता है? पुराना इतिहास बता दूं तो आप थोड़ा सा अच्छा लगेगा, पढ़ के देखिएगा, एंड यू कैन सर्च इट ऑन गूगल आल्सो। टेस्ला एंड एडिसन ये दोनों कंटेम्परेरी थे, एक साथ थे दोनों, टेस्ला एंड एडिसन, थॉमस अल्वा एडिसन। एडिसन ने प्रपोज किया था उन दिनों डीसी को, और एडिसन बहुत स्ट्रांग थे गवर्नमेंट में, बहुत स्ट्रांग थे, क्योंकि उन्होंने बल्ब बनाया था और उन्होंने डीसी को प्रपोज किया था पूरे अमेरिका में लगाने के लिए, और उनके एम्प्लॉय थे निकोलस टेस्ला, उनके यहाँ नौकरी के लिए आए, किसी ने भेजा था और नौकरी कर रहे थे। उन्होंने एडिशन का विरोध किया कि सर दिस डीसी ट्रांसमिशन इज नॉट गुड, डीसी डिस्ट्रीब्यूशन सिस्टम इज नॉट गुड, हमें एसी लगाना चाहिए। अब थॉमस अल्वा एडिसन इतना पैसा लगा चुके थे, इतनी इंडस्ट्री सेटअप कर चुके थे कि उन्हें लगा कि अगर ऐसा कर दिया गया तो मेरा सब कुछ बर्बाद हो जाएगा। तो उन्होंने फिर षड्यंत्र रचना शुरू किया, इनको फंसाया। पहले दिन को एक ऐसा टारगेट दिया कि जो लगभग असंभव था, कि ये मुझे पता था एक जनरेटर में प्रॉब्लम आ गई, एक डीसी जनरेटर में प्रॉब्लम आ गई। जगह जगह डीसी जनरेटर लगते थे बहुत जगह पर, क्योंकि इतने बड़े एरिया में पूरे ट्रांसमिशन वायर्स नहीं थे। तो उन्होंने उसमें जनरेटर में प्रॉब्लम आ गई थी, तो उन्होंने निकोलस टेस्ला से कहा कि यू कैन करेक्ट इट, देन आई विल गिव यू दिस मच मनी ऑफ रिवॉर्ड। टेस्ला ने उसको लग करके ठीक कर दिया, लेकिन एडिशन पैसा देने से मुकर गए। व्यापारी आदमी थे, साइंटिस्ट भी थे, व्यापारी भी थे, वो पैसा देने से मुकर गए। टेस्ला को बहुत खराब लगा, टेस्ला ने उन्हें 10 बातें सुना, नेचुरली लॉजिक आदमी, उन्होंने टेस्ला को फायर कर दिया। टेस्ला जमीन पर आ गए। फिर वेस्टिंग हाउस करके कंपनी थी, आप लोग कहीं कहीं पर नाम देखते होंगे, वेस्टिंग हाउस पुराने टाइप की कंपनी। वेस्टिंग हाउस ने फिर इनको थोड़ा सा टेस्ला को सांत्वना दी और थोड़ा सा मोटिवेट किया, तो ये पहली बार एसी सिस्टम लेके आए। आगे की कहानी आप लोग पढ़ लीजिएगा या देख लीजिएगा, क्योंकि ऐसे तो बहुत मेरे पास कहानियां प्रैक्टिकल से भी रिलेटेड है, इलेक्ट्रॉनिक से भी रिलेटेड है। अंत में आज की तारीख में हम आते हैं तो वी हैव एसी डिस्ट्रीब्यूशन सिस्टम इन आवर हाउसेस, जो कि निकोलस टेस्ला ने दिए। लेकिन लॉन्ग डिस्टेंस ट्रांसमिशन डीसी ट्रांसमिशन, जो कि थॉमस अल्वा एडिसन का आइडिया था। और इस बीच में एक आता है एक और आइडिया जो कि अब नहीं हो पाया उस समय, निकोलस टेस्ला का था वायरलेस इलेक्ट्रिक ट्रांसमिशन, और उसके लिए उन्होंने कुछ काम किया था, और ऐसा माना जाता है कि उन्होंने जनरेटर बना लिया था, लेकिन उसकी फाइल गायब कर दी गई। आज तक वो पूरी डिजाइन थी वो गायब है। तो इलेक्ट्रिक वायरलेस इलेक्ट्रिक ट्रांसमिशन अभी भी नहीं हो पा रहा है। क्या प्रॉब्लम्स थी, क्या नहीं थी, that is again even it is a point of research. So there are various lots of problems and opportunities and challenges in electrical power system. महासागर है ये, एक बार जाके देखिए। थैंक यू।
Thank you, sir, for enlightening us and sharing your great knowledge with us. Now, I would like to invite Dr. B.D.K. Patra, sir, to for his inspirational words.
Chief guest of today's event, Director Sir, HOD Electrical Silpi Ma'am, all the conveners, coordinators of this event, Santosh ji, Kamlesh ji and Vijay ji, our ex-registrar Ravi ji and Abhishek ji, and all the teachers and my dear friends, students. Thanks for giving this opportunity. So मैं ज़्यादा बोल के बोर नहीं कहूँगा, सर ने बहुत बढ़िया चीज़ बोले हैं. First of all, I congratulate the department for organizing such FDP that will help all the faculties and participants for gaining some स्मार्ट ग्रिड जब बात करें, इट्स लेटेस्ट एंड स्मार्ट। आजकल जब भी स्मार्टनेस की बात आता है, चाहे स्मार्ट कैंपस हो, स्मार्ट मोबाइल हो, स्मार्टफोन हो, या स्मार्ट स्मार्ट बिल्डिंग हो, या स्मार्ट ग्रिड हो, तो हर चीज में स्मार्ट मीन्स देयर इज सम ऑटोमेशन, देयर इज सम कंप्यूटेशनल कैपेबिलिटी, देयर इज सम computing environment attached to it that maintains, that automates the thing. आईआईटी कानपुर में मैं एचओडी साहब से मिला था, वो इसी फील्ड में रिसर्च कर रहे हैं। दैट मीन्स मैं ये बताना चाहता हूँ, द टुडेस रिसर्च इज इंटरडिसिप्लिनरी इन नेचर। चाहे कंप्यूटर, इलेक्ट्रॉनिक्स और इलेक्ट्रिकल, सबको मिलके इस पर्टिकुलर एरिया में काम करना चाहिए टू इन्वेंट, टू वर्क ऑन न्यू रिसर्च इन दिस पर्टिकुलर एरिया। तो स्मार्ट ग्रिड में एक सबसे बड़ा चैलेंज है कि अगर आपका ऑटोमेटेड एक स्मार्ट ग्रिड है जिसमें कि ह्यूमन इंटरवेंशन बहुत मिनिमम है, उस केस में आपको उसका सेफ्टी, सिक्योरिटी, उसको मेंटेन करना एक बड़ा चैलेंज हो जाता है, तो बड़ा थ्रेट है। तो उसमें कंप्यूटर साइंस का एक मेजर रोल आता है कि आपका जो एनवायरनमेंट सेट किया स्मार्ट ग्रिड है, उसको एक्सटर्नल एजेंसीज कोई हैक ना कर सके। एक बार हैक कर दिया तो मालूम पड़ा पूरा दिल्ली बैठ गया, मैन्युअली कोई ठीक नहीं करेगा, जब तक वो एक्सपर्ट नहीं आएगा उसे ठीक नहीं करेगा, चालू नहीं हो पाएगा। तो देयर आर डिफरेंट challenges in this area also. If you work on it and take the help of different other disciplines also, that will help in more new things that can be that is possible to design and develop. So with these words I stop here. Again I congratulate the organizing. Thank you.
Thank you, sir, for your great knowledge on this topic. Now, the online session of FDP will continue, and Rajiv, sir, of GB Pant University will take over the first section of this event.
वो कंटेंट किसके बारे में? कंटेंट
यही बैठेंगे।
मैम से बोलते हैं आप अपने सिस्टम पे लॉगिन कर लो, हम आपको, हाँ हम आपको यहीं से आपका वो कर देंगे। उनको होस्ट नहीं बनाना है हमको, हम उनको जो भी पार्टिसिपेंट होते हैं, मैं उनके वो बोल सकता हूँ, अभी सबको म्यूट कर देंगे उनको।
And if the music continues in specific restrictions, they can continue it.
पागल है माइक बंद किया था लाइट पर
told you. So these are basically the categorization. This figure 3, it shows the basic categorization of the power levels or the EVSE power ratings. So coming on to the battery swapping. So an alternative battery recharging method that is, receiving nowadays global attention, it is the battery swapping, in which a depleted electric vehicle battery is removed from the vehicle, and it is replaced with a fully charged. And this technology is being tried out for various EV segments, including electric two-wheelers and cars, and even it is being tried out for the electric buses. So what are the various types of battery swapping uh, that are being used nowadays? So mainly there are two types of battery swapping. The first one is your manual swapping. That is, the battery swapping station here in the manual swapping is a standalone device, particularly in which the batteries are placed and removed manually from the individual slots, usually by hand. The manual swapping stations are modular and occupy a minimal amount of space, and these are used for two kilowatt and 3 kilowatt battery applications, particularly as the battery pack sizes are smaller, and the weight is also lesser, and hence it can be handled by one or two. So the type second type is your autonomous battery swapping. So how it is different? In the autonomous battery swapping, a robotic arm is used in these types of swapping stations, particularly with the battery swapping process being either semi or fully automated. Mainly the robotic swapping is used for 4 kilowatt and electric buses applications, as the battery packs are larger in size, and hence they are very heavy as well, and they require mechanical assistance for this because of the size and the weight of the battery pack. And these swapping stations are also more expensive, and they hence require higher land requirements. So mainly, the battery swapping has some distinct advantages over the plug-in charging, and is also confronted with several challenges in its development as a mainstream charging method. So we can have these advantages as well as disadvantages, or you can say, or the challenges of battery swapping, which is hindering its for bringing it as the mainstream charging technology. So mainly the advantages, it can be enumerated, or it can be simply listed as the EV recharging is completed within minutes. Particularly, it requires very less time is there, or it requires very less time. However, batteries, they can be charged away from the particularly from the swapping point, and this allows for more freedom, and you can say more flexibility in the operation, and also you can say that some kind of more flexibility in setting up these kind of swapping facilities. So this is your second advantage for battery swapping. So next thing is, and very important one, is reduction in the upfront cost of the electric vehicle, as the battery ownership is replaced by battery leasing. Here, the battery pack is not actually owned by the EV owner, but instead it is leased, particularly because you have to swap the battery after it is getting discharged. So there is leased ownership, so there is a kind of reduction in the upfront cost of these electric vehicles. So second one is your increased predictability of the battery life due to controlled charging conditions. If you are charging it somewhere else, at a different point and under controlled charging conditions, you can, predict the life of the battery more accurately. So this is what is the meaning of this point. So what are the barriers? Barriers are particularly your lack of standardization among the EV batteries, because you know that different types of electric EV batteries are used, and for swapping, there is, particular standards have not been made for, but still they are in their, at their your infant stage. So you don't have very strict, standardization practices which are available here in this battery swapping. Mainly your sometimes your battery pack design, or its weight and dimensions, and including your ergonomics, they are some kind of barriers for transporting it from one place to another, particularly when you are swapping it or you are changing it within the electric vehicle. Not only this, but greater number of batteries are also needed to power the same number of EVs. In case the batteries, some batteries will be in the charging stage and some will be used in the electric vehicles. So almost twice the number it will be required. So these are, certain barriers, including the shorter commercial life of the battery packs due to your customer preference for new batteries, because nobody will prefer your used batteries after some time. So all these can be the barriers or challenges which are involved, particularly with the battery swapping. So at present, the battery swapping is considered as a feasible solution for commercial EV fleets, particularly in your electric two-wheelers and electric three-wheeler sectors. And our ministry, particularly the Ministry of Road and Transport in our government, it has allowed the sales and registration of electric vehicles without batteries, which provide a huge boost, to the battery swapping solutions. Further, also, there are, industry stakeholders. They are also making large investments in developing the battery swapping ecosystem. And this indicates that in the future, the battery swapping will emerge as a, distinct part of the EV charging networks in India, particularly in our country, uh, in the coming years. Now, having understood the different types of, you know, charging and the power levels, the battery segments, we can now come to your next point. And the next point is your EV charging standards for your interoperability. So what basically your EV charging standards mean? Mainly, standards ensure interoperability and compatibility of any EVSC with all electric vehicles. And in India also, the Bureau of Indian Standards, that is our, national standards body in India, it is responsible for formulating the EV charging standards in our country. And so BIS is a member of, International Electrotechnical Commission, which is the global body that is developing the reference standards to ensure the interoperability and minimize the trade barriers for the electric vehicles and their components. While Indian standards for electric vehicles are compliant with the global standards, you know they are compliant with the global standards. Local climate considerations and the differences in the vehicle types available in the country, it necessitates the modification uh, of these standards, particularly in reference to our country, that is, which are applicable specifically to India. So if you observe, these are the mainly your different standards which are prominently adopted, and will be this table here. Basically it gives you the different power levels, as well as the charger location and the power and the current levels which are used by the different standards. That is, first one is your Society for Automotive Engineers, that is SAE standards. SAE standards. From this table, it can be observed that SAE standards uses level 1. Level 1 is for AC charging, and basically in the level 1 charging, 230 volt it is used in European Union, and 120 volts it is used in USA. So here basically we use your single phase AC, and the charger is a onboard charger that we use in this category. That is SAE standards. And the power and the current rating is your 1.4 kilowatts and 12 amperes. Okay, and also we have 1.9 kilowatt charger having this much of power requirement and 20 amperes. So this is your SAE standard for level 1 charge. For level 2 charging, you have, again, this is used as AC charging, and 400 volt it is used for it is used in European Union, and 240 volt in level 2 charging it is used in USA. Here also we use a single phase, either we use a single phase charger or we use a 3-phase charger which is placed on board. Okay, so what are the power requirements? These three are the power and the current requirements. 4 kilowatt with 17 amperes. There can be a 8 kilowatt charger with 32 amperes. And there can be 19.2 kilowatt with 80 amperes. Then we have level 3 AC charger. In the SAE standards, we are talking particularly about the SAE standards. We have level 3, which is AC charging, and here the voltage is, it is in the range of 208 to 600 volts, and normally we use a 3-phase AC supply, and again an off-board charger is used, so the power requirements are 50 kilowatts and 100 kilowatts. So next one is, in the DC charging also we have 3 levels here again. That is level 1 DC charging. The voltage lies in the range of 200 to 450 volts particularly. The charger is again an off-board charger, and the power requirement is your 40 kilowatt with 80 amperes current. Then in the level 2 charging, which is DC charging in SAE standard again, it is your 200 to 450 volts. It contains an off-board charger, or the charging mechanism is off-board charging, and the power requirement is 90 kilowatt with 200 amperes. So next is your level 3 DC charging. Level 3 DC charging is again between the voltage rating, or you can say the voltage level is between your 200 to 600 volts, and it involves a off-board charger, and the power and the current ratings are 240 kilowatt with 400 amperes. So this was about your different levels of AC and DC charging which are present in your SAE standards. That is Society for Automotive Engineers. They have prepared as standards for charging which is being used. The next one is the most prominent one, and almost our standards, that is Indian standards, have been influenced by these international electrotechnical commission standards, particularly, as I have already told you, that BIS is a it is a body which is in touch with your IEC. for designing our standards. So IEC standards, they also use level 1, level 2, and level 3, as well as DC fast charging. So level 1, level 2, and level 3, they are AC charging. So level 1 charging, it involves a single phase supply. Onboard charger is there, and the power rating is in the range of 4 to 7.5 kilowatt with 16 amperes. Then level 2 charging is again, AC charging, which is adopted by IEC standards. They contain, they involve particularly single phase as well as three phase supply, and the charger are onboard charger, and the power rating is in the range of 8 to 15 kilowatt, and the current rating is 32 amperes. Next is your level 3 charging, which is also AC charging, and that is, uh, that involves basically single phase as well as three phase charging, and onboard and offboard chargers both are used in this type. There is level 3 AC charging adopted by IEC standards, and from 60 to 120 kilowatt is the power range in this category, with 250 amperes is the current rating which is used. Finally, the DC fast charging, which is adopted by the IC standards, it involves off-board charger, and the power rating is from 1000 to 2000 kilowatt, with 400 amperes. Now the third one is CHAdemo standard. It is particularly prepared by Japan, and it involves mainly your DC fast charging. And the DC fast charging, it involves off-board charger, uh, and the power capacity is 62.5 kilowatt with 125 amperes current. So not only this, there are many other standards also, but these are the prominent ones. So I have used them here. There can be other standards. We are not going to discuss because that will be very elaborated one. So now coming on to your our own, that is Indian standards. As I have told you that you know basically the standards ensure the interoperability and compatibility of any EVSC with all EVs. So interoperability means what? Interoperability means you know that you can use chargers for any kind of electric vehicles. So because that there are different manufacturers of EVSE as well as EVs. So if you adopt certain standards, those chargers can be used for any electric vehicle, or you can say charging of any electric. So that is kind of interoperability. It can be used for interoperability. So coming on to the Indian standards particularly, the Bureau of Indian Standards, as I have already told you, that it is a national standards body in India, and it is responsible for formulating the charging standards for the country. And BIS is also a member of the International Electrotechnical Commission, IEC, which is the global body that is developing reference standards to ensure the interoperability and to minimize the trade barriers for electric vehicles and their consumers. I have already told you about this. So while the Indian standards for electric vehicle charging, they are compliant with the global standards, but we have to adopt uh, those standards particularly so that they can be pruned as per our requirements, or as per the requirements here in India mainly. So coming on to the next point, that is, briefly about the Indian standards. Indian standard, IS 17 170 17 is the key EV charging standard in India, and it comprises three parts and six sections. That is IS 170-17 Part 1, which provides the basic features of all EV charging systems. And AC EVSE, mainly it must adhere to to these standards, and also to the specific AC connector standards in the Indian standards 170-17 Part 2. So both the AC as well as DC EVSEs, they need to conform to the technical standards which have been adopted, particularly 170-17, Part 1 and Part 2 both. Additionally, Indian standards for AC EVSE, have also been approved for light electric vehicles and electric cars, and mainly they are used particularly in the parking areas mainly. So for DC charging, coming on to the Indian standards for DC charging, mainly your IS 170-17 Part 23, it describes the requirements for DC charging stations with power output of 50 kilowatt to 200 kilowatt. And beyond this, high power charging standards are required, to cater to the buses and also to the heavy vehicles. So recently, the Bureau of Indian Standards, it has finalized the IS 170-17 Part 25, which is specifically for providing low DC power to less than 7 kilowatt of light electric vehicles. Now, due to the requirements of digital communications between the DC EVSE and the EV, mainly the data communication standards, they are also specified in Indian Standards 170-17 Part 24. Uh, when the combined charging system, that is CCS standard, is deployed, this can provide both AC and DC charging, and the communications will be as per your Indian standards 1500, sorry, it will be as per your Indian standards 1511-8 series. Now, in addition to the conductive charging, there are certain Indian standards for battery swapping also. Mainly your separate projects, they have been initiated for battery swapping standards for light electric vehicles as well as buses. And particularly for these standards, there will be two series of standard documents covering the form factor of the battery pack, its interoperable connection systems, and the communication between the battery management system and the electric vehicle and charging station and the network management. So any electric vehicle may utilize a battery pack conforming to these standards. Particularly the removable battery packs, they can be charged using AC or DC charging systems. So uh, these type of, this type of process is going on in order to prepare Indian standards for battery swapping. So coming on to the various, connectors and the ports which are used in the different countries for different type of, charging. Mainly the AC and DC charging is characterized by the connector types, ports, and the charging power levels. So every country, it allows its own charging standard, and the major difference, it particularly lies in the ports and the connector types used for these, charging levels. So level 1 and level 2 chargers are mostly designed for private charging, while level 3, that is off-board DC fast chargers, are designed for public place charging particularly. Chargers with level 2 specifications are designed for outdoor and indoor use, conforming to the National Electrical Manufacturers Association, that is NEMA, defined standards such as NEMA 6P, NEMA 4X, and NEMA 3R. Your DC off-board fast chargers allow three different types of connector specifications. There is combo charging system, that is CCS, CHAdeMO, and also Tesla supercharger. The CHAdeMO standards was, developed by, as I have already told you, it was developed by Tokyo Electric Power Company and some other Japanese automakers. SAE also, it has established its own DC fast charging standards, that is CCS, instead of adopting CHAdeMO. Likewise, Tesla have also developed their own proprietary fast charging systems branded as Tesla Supercharger, and China has framed their own GB slash T fast charging standards. So CCS standards uses combo 1 and combo 2 connectors with additional DC contacts to supply power levels up to 350 uh, kilowatts. And some your revised CHAdeMO specifications, they use your 1000 volt 400 ampere DC to supply power up to 400 kilowatt. The Tesla supercharger, however, it uses a three-phase supply to convert it to a 480 volt DC for fast charging of EVs. In addition to this, USA and Japan use both AC and DC charging for EV, facilitated by using level 1 and level 2 charger ports and connectors that conforms to SAE 1772 standards. And the Tesla, it uses its proprietary connector and port both for fast charging. In addition to this, Tesla has also introduced SAEJ1 1772 connectors. Particularly these connectors, they can be used in the supercharging stations, particularly directly. A different type of connectors which is normally used in Europe, it involves different charging model, and that connector is called combo, which uses additional pins for DC charging into the existing AC connectors for charging. Level 1 and level 2 charging ports and connectors are used in Europe that conforms to IEC 62196 standards. And with respect to EV manufacturers, European and American EV manufacturers have adopted combo type, while the Japanese EV manufacturers have adopted CHAdeMO, and the Chinese EV manufacturers have adopted GB/T standards. So therefore, it can be seen that the EV charging equipment manufacturers have not agreed upon a single international standard. So there are different standards, and the organizations and governments are making efforts to develop uniformity in the charging standards and frame a universal solution for EV charging. So here we have the summary of standards and voltage levels which are particularly used in your various standards. So mainly your international standards, your IEC, you can say standards, they are of these two. We have these two, IEC standards. And here we can see that what are the voltage levels, particularly in IC 162196. The source is particularly AC, and mode or level, it is said to be mode 1, and the voltage level is again 120 volt, phase is single phase, maximum current level is this. So this table basically summarizes the current and voltage levels which are adopted in different, you can say, uh, charging standards. So the advancement of electric vehicles, basically it has opened up, new prospects both in transport and power sector. And to develop uniform charging infrastructure worldwide, it is necessary to standardize each aspect of electric vehicle. The standards basically listed here in this table, which is shown, it summarizes a few international standards that governs the various aspects of electric vehicles. And these standards, they are related to electric vehicles, and they can be categorized into, three sections. That is EV charging components, grid integration of EV and safety standards, International Organization for Standardization, that is ISO. It works on the standardization of whole electric vehicles, and a few other organizations, they work on elementary specifications. So the EV charging or discharging, it comes under grid integration standards. When integrated with a power system, EVs act as distributed energy resources, and the standards for integration of distributed energy resources with the grid also apply on electric vehicles. So these standards, particularly, they have to be, managed in that way. So coming on to the references that I have used here, these are the references. This was all about your various types of standards and voltage and power requirements, and the different types of, connectors and the pins that we are using. So if you have any questions, please, I would like to answer those questions.
क्या खाली हो जाते हैं
If you have any queries to sir, am I audible?
Yes, yes, yes.
Okay, participants, you can ask questions from the resource person, sir. If you have any type of doubt, any type of query regarding the electric vehicle charging and their standards.
Hopefully there are no questions, I think. Kamlesh ji?
Yes, sir. So I'm Shilpi Yadav from the
Yeah,
Electrical
Shilpi
Engineering
ji.
Department. Yes,
Good.
sir. So yes, I think, sir, there's no query from the participants' end.
Sure,
Thank
sure,
you so
sure.
much, sir, for giving
Thank
the
you, ma'am.
valuable information
Thank you,
on
ma'am.
this topic. This is very useful topic and recent topic. You have covered, I think, all the content related to it very clearly, and hopefully participants learn from your lecture.
It is expected, ma'am. I have tried to cover most of the things.
Yeah,
Uh,
yes, sir. So
we
nicely,
can,
sir.
and we can be, I mean, the participants, you can share my email ID to the participants if they have any other queries related to this talk, or anything related to, EV charging stations or electric vehicles particularly. They can contact me on the
Okay,
email
okay,
also.
okay. Yes, sir.
Thank
Thank
you.
you so
Thank
much,
you.
sir, for the
Thank
nice
you, ma'am.
session.
Thank you, ma'am.
Okay.
Thank you.
Thank you, sir.
Thank you.
Participant, this session has been closed. The second session of this first day program will start around 2:30 p.m.